Hello everyone. Myself, Jasmine SP, Assistant Professor, Department of Civil Engineering, Vedavyasa Institute of Technology. Today, I am here to give a tech talk on the topic retrofitting of RCC structures. These are the overview of my presentation: retrofitting, need of retrofitting, advantages of retrofitting, retrofitting techniques, global retrofitting techniques, and local retrofitting techniques. Retrofitting is the upgrading or strengthening of the existing structures to make them safe and resistant to natural hazards. If an existing RCC structure may get damaged due to poor design or due to natural hazards such as earthquake, flood, heavy wind, etc., there are two possible solutions. One is the replacement of the entire structure. For replacing the entire structure, first we need to demolish the existing structure and we have to dump the demolished concrete waste to some other place. Dumping of the demolished concrete waste to the environment is very hazardous to the environment and it causes strong environmental impact. Also, replacement of the structure is uneconomical and it is very time consuming and causes inconvenience to occupants. Another solution for such a problem is a retrofitting. Retrofitting means strengthening of the existing structure. It proves to be a better economic consideration and immediate shelter to problem rather than replacement of the building. Retrofitting can be done on beams, columns, beam column joints, walls, foundations, and on girders. Existing RCC structure has faced so many problems. They may have structural crack and some of the structural member may get damaged due to natural hazards or excessive loading. There are chances for errors in the design or construction. They may have sometimes excessive loading and earthquake may cause severe damage to the structure, that is seismic damage. Sometimes the functionality of the structure may be changed. For example, if an auditorium is converted to an industrial building, the load acting on the auditorium is different from the load acting on the industry. In the case of an industrial building, there were so many heavily loaded machineries, etc. So, industrial building is heavily loaded compared to an auditorium. So, before converting the auditorium to the industrial building, we have to retrofit the building to meet the requirements of an industry. Next problem is the corrosion due to penetration of the surrounding water into the RCC structural elements. It leads to the corrosion to the steel inside. Next is the advantages of retrofitting. Retrofitting is economical and it is immediate solution to the problem and it improves the serviceability of the structure. Retrofitting make building more suitable for intended use. By retrofitting, loads may be immediately applied, that is no curing time is required. If you are replacing the entire structure, it need nearly 1 to 2 months for curing the new structure. But in case of retrofitting, without interfering the function or the use of the building, we can retrofit or strengthen side by side. Retrofitting enhances the strength and it increases durability. Retrofitting techniques. Retrofitting technique is mainly divided into two, that is global retrofitting techniques and local retrofitting techniques. The retrofitting in which we use to repair the whole structure is called global retrofitting. The retrofitting in which we use to repair only the structural element is called local retrofitting. For example, in an RC structure, if we are repairing only some of the beam or some of the column or some footing, then we can go for local retrofitting. Or if we have to strengthen the entire structure, we can go for global retrofitting. I have listed some of global retrofitting techniques and some local retrofitting techniques. Global retrofitting techniques include adding shear wall, adding bracing, adding buttress wall, mass reduction, base isolation. Local retrofitting techniques include RCC jacketing, steel jacketing, fiber reinforced polymer sheet wrapping. There were so many retrofitting techniques. I have listed some of them here. Moving on to the global retrofitting techniques one by one. First retrofitting technique we are going to discuss is adding shear wall. I have included a RCC structure. I have shown a RCC structure here, framed RCC structure with shear wall. A new shear wall can be cast in situ or precast concrete element. It can be placed at the exterior wall of the building. However, it may cause in the appearance increase in lateral strength, ductility and stiffness of the building. Next retrofitting technique is adding steel bracing. Here the figures show a framed RC structure with steel bracing. It is an effective solution when openings are required. Compared with the adding of the shear wall, here the shear wall covers the entire area. It does not permit exterior light or ventilation to the interior of the building. Compared to the shear wall, bracings provide opening for natural light and also it add much less weight to the existing structure. Bracings also increase strength, ductility and stiffness to the RCC structure. Next global retrofitting technique is the adding of buttress wall. From the figure, it is very clear that buttress wall are constructed outside the building. It increases lateral strength, ductility and stiffness to the structure. The buttress wall are placed on the exterior side of an existing frame. The advantages of this technique is that we can retrofit this structure without interfering the function or use of the structure. This is a RCC framed structure. Here the buttress wall is constructed outside the frame. Next retrofitting technique is the mass reduction. In this process, one or more story of the building may be removed. It reduces the load at the foundation and increases the life and the strength. This retrofitting technique is used to make the structure more resistant against earthquake and wind. Next retrofitting technique is the base isolation. Isolation of superstructure from the foundation is called base isolation. Superstructure are the structure above the ground level and foundation or substructure are the structure below the ground level. Isolates building from ground motion, hence lesser damage to the structure. In base isolation technique, we are introducing bearings like this. Bearings are introduced between the superstructure and substructure, and when happens an earthquake, the bearings may provide stability to the superstructure and it causes less damage to the structure and it does not involve major intrusion upon existing superstructure. Moving on to the local retrofitting techniques. First one we are going to discuss is the RCC jacketing. It involved addition of layer of concrete, longitudinal bars and closely spaced ties. The jacket increases both the flexural strength and shear strength of the member. If the jacket is only partially around the existing member, the new bar can be welded to the existing bar. Here I am showing an RCC column jacketed. This is the existing RCC column and this is a new RCC column constructed. These are the longitudinal reinforcement provided and these are the lateral ties. These lateral ties connect existing RCC column and a new RCC column, and it confine the existing column with the new RCC column, and it perform the composite action of the existing and new one. Next retrofitting technique is a steel jacketing. It refers to encasing the member with steel plate and filling the gap with non-shrink grout. Here the beam and the beam column joint is retrofitted with steel jacketing. Steel plate were provided. Between the steel plate and concrete, non-shrink grout were poured. Here I included an example of the beam. The plates are attached to the tension face of the beam to increase the flexural strength, whereas they are attached to the side face of the beam to increase the shear strength. In the case of a beam, if it is observed that the beam is weak in taking flexure, then we can provide steel plate on the tension face of the beam, and when it is observed that the beam is weak in taking shear, then the steel plate can be placed on the side faces of the beam, so that steel plate can be provided by understanding the behavior of the member. Next local retrofitting technique is the FRP sheet wrapping. FRP are thin, light and flexible material. FRP means fiber reinforced polymer. It has high tensile strength and corrosion resistance. Retrofitting with FRP increases ductility without noticeable increase in size. Increase in thickness of wrapping improve the strength and ductility. Here the beam column joint is retrofitted using FRP sheet. FRP is very thin lightweight material. It is like a cloth and it is very easy to retrofit with FRP sheet. Hope all of you may get some idea about retrofitting and types of retrofitting techniques. Thank you.